All right, everybody. So today we will discuss about the subatomic particles. So by looking at this periodic table, you can see that you've got a lot of boxes like this, which I'm trying to make. So this is an elemental notation for carbon. So you can see there's a small number and there's a big number. So the small number is your atomic number. It basically lets you know about the total quantity of electrons or the total quantity of protons. Whereas the big number is your atomic mass, which lets you know about the sum of neutrons plus proton. So if there's a question that we need to find out the subatomic particles of carbon by looking at this elemental notation, so what we are going to do is we are simply going to make sure that we follow some simple steps. So now if we see this small number, you can see that I've got my electrons as 6 over here, my protons as 6, because this atomic number, like the small number, lets us know the total quantity of protons and the total quantity of electrons, right? Now, as for the number of neutrons in this carbon, what I'm going to do is I'm going to subtract this sum by this number, like this big number by this small number, and I'll eventually get the number of neutrons. So 12 minus 6 will give me an answer of 6. So these are my subatomic particles, which I can easily calculate by calculating and by assessing the numbers in the way I've exactly shown you how you can calculate these, right? So now here's a practice problem. Let's say if I have lithium, so an elemental notation of lithium is shown as you can see with a number 7 and a number 3. So if we were to calculate the number of electrons, they would have been 3, the protons would have been 3, all because of the fact that we've got our atomic number as 3, which lets us know the total quantity of protons and the total quantity of electrons, right? Now, as for the big number, it will get subtracted by the small number in order to get the exact quantity of neutrons. As we know that this number is the sum of neutrons plus proton, so I'll have to make sure that I deduct the total quantity of protons from this sum in order to find out the number of neutrons. So you can pause this video and you can see this again, how I'm exactly trying to calculate the subatomic particles, right? Now, once this is done, we will move forward towards electronic configuration. So as for the electronic configuration, if we have an example of boron, we have this example, this is 5. So I'll quickly erase this and I'll make sure that we write 5 clearly. So now for the subatomic particles, we've got our electrons as 5, our protons as 5, and then 11 minus 5 will be 6 neutrons, right? Now as we know that we have got our atom, and the atomic structure is in a way that we have got a nucleus in the center where we have neutrons and protons inside the nucleus, and then eventually we have got a lot of orbits around the nucleus, and in these orbits we have got our electrons. We've got our electrons, right? Now I'll quickly make sure that we come up with an electronic configuration or the atomic structure for our boron. So now if this is basically an atom of boron, it would look like this. As atomic structure, it would look like this. It would appear to be something like this, that the nucleus would have 6 neutrons and the protons would be 5 in this nucleus. Whereas for the first shell, always remember, in the first shell we can always have a maximum number of 2 electrons, because the first shell is called as duplet and it can only accommodate maximum number of 2 electrons. Whereas for a shell which is octet, so the first shell, always remember, the first shell is duplet, whereas the second shell is octet. So octet can accommodate 8 electrons, whereas duplet can accommodate 2 electrons. Now for the second shell, and similarly the other shells like the third shell, fourth shell will accommodate 8 electrons and similar. So yes, I'll quickly make sure that we make the remaining electrons. So we have accommodated 2 electrons, so the leftover electrons would be 3, right? So the 3 electrons would be accommodated in this way, right? So as you can see, I've made my nucleus, we have made our orbits. In the first orbit we have got 2 electrons, in the second orbit we have got our 3 electrons. Now by assessing a few things with respect to this diagram, with respect to this atomic structure, we can find out the number of group and the number of period by looking at this electronic configuration. We can also say this as an atomic structure, right? Now, by looking at the shells, we will count the number of shells. So the number of shells are 2, so my period is going to be 2. Whereas for groups, always look for the valence electrons. So the valence electrons over here are 3. So what do I mean by a valence electron? So anything which is in the last shell is called as a valence electron. So basically the last shell is called as your valence shell and the electrons inside it are called as your valence electrons. So technically you've got 3 electrons, so this element belongs to group 3. So this is how things are happening. Now we will move a little further with the concept of valencies as well. So for group